Alright, let's look at the homework 11.5, problem number 7. Alright, so let's test the convergence of this alternating series. Alright, so let's identify Bn first. Looks like sine of 5 pi over n is going to be our Bn. Right, so we're going to do an alternating series test. So alternating series test. Right, so first to check is make sure that the Bn is a decreasing sequence. Alright, so let's do that. I'm going to use calculus to show this. Alright, so I'm going to let function f of n to be the same formula as sine of same formula as Bn, sine of 5 pi over n. Right? So we want to show that this is decreasing, so I'm going to take the derivative and show that the derivative is non-negative, actually non-positive, I should say. Alright, so let's take the derivative. So f prime of n is equal to, derivative of sine is cosine. Alright, so leave the inside function as it is and take the derivative of inside function, so 5 pi over n with respect to n, which would be negative 5 pi over n squared. Alright, so we're going to show that it's going to be non-negative. So here, this portion is definitely always negative. So that's good. And so we want this cosine to be positive. But unfortunately, it does not follow that pattern when n is first few n. And for example, if cosine of n equals 5, so let's say cosine of pi, then cosine of pi is actually negative 1. So it does not work. So we want this number, 5 pi over n, to be less than pi over 2, or less than equal to pi over 2. So that happens when n is 10. So what we're going to do is I'm going to say if n is at least 10. Right? If that happens, we know that 5 pi over n, when n is at least 10, then it's going to be at most pi over 2, because 5 pi over 10 is pi over 2. So cosine is going to be less than or equal to 0. Right? Which means that, oh actually, sorry, the other way around. It has to be greater than or equal to 0. Right? So if that's the case, then we know that this is going to be non-positive, because this part is negative, this part is non-negative, so it's going to be non-positive. Alright, so once you've done that, then we know that as long as n is greater than or equal to 10, we know that the corresponding sequence is going to be decreasing. So I'm going to say for all n starting from 10. Right? So that first the condition is verified. Alright, so let's do number 2. Number 2 is fairly simple. We just need to make sure that the limit of Bn as n approaches infinity is going to be equal to 0. So this is going to be a limit. Bn is a sine of 5 pi over n as n approaches infinity. Alright, so this is going to be, right? We know that as n approaches infinity, 5 pi over n approaches 0, so this is going to approach sine of 0, which is 0. Alright, so this is, so second condition is satisfied. So therefore, by alternating series test, the series in question converges. All right, so let's type it in. All right, so it's gonna converge and submit for testing. All right, it came back and looks like we got this one correctly. All right, that's it. I hope that this was clear.